Okay, so first of all, thank you all for coming. Glad that you got some food. And second of all, thank you for taking the needs assessment survey a couple weeks ago. This whole class is kind of based off of that survey. We're making a PD, and then we're going to analyze our results from the PD. So there were 9 science teachers that took the needs assessment survey, and out of those 9, inquiry-based learning was a need and a support that most all the science teachers wanted, so I chose to do my professional development based off of that. So I made this PD to be done job embedded, meaning that you could do it on your own. I could just send out this PowerPoint and everybody could go through it and do it on their own time. Or it could be done as I'm doing it now, more like workshop in collaboration style. So you'll need a pen and pencil, or a pen and paper, which I gave you the paper. And then just kind of have some ideas about lesson plans or labs or activities that you might want to make more inquiry-based. So we're going to start off going through some of the core principles and just kind of look at the different levels of inquiry-based learning. Surprisingly, we probably all do this already, but there's kind of more of like an advanced level that we want to get to. So we're going to look at some examples of inquiry-based learning in high school science classrooms. And you will then have time to redesign one of your own lessons using a checklist that we're going to get to later on in the presentation. We'll talk about an action plan, kind of what our next steps are, and our goal is to have these inquiry-based lessons ready to bring to our next science department meeting. So main benefits of inquiry-based learning, the reason that we want to start doing this in our classrooms is to really get students to be more involved in critical thinking, to work on their problem-solving skills, to give them kind of more control over what they're learning and how they're going to explore and learn those topics. So encouraging more engagement, which again in science that tends to be a little bit easier because we do have lab activities that we do with our students, so that kind of already brings in that engagement. But also really connecting our learning, or students' learning, to real world experiences, which I kind of find that's sort of where I struggle. I'm usually so focused on what they need to know, I kind of forget about how that can be applied. So that helps with the inquiry-based learning as well. So on your paper, just a quick little warm-up activity, just jot down a few notes. What does inquiry mean to you? What do you kind of see that looking like in your classroom, or what do you think should be happening in an inquiry-based learning classroom?
So what does inquiry in action mean? What, not just what the word means, but in action.
Yeah, or you know, what does it mean? What should students be doing if they are engaged in inquiry-based strategy? Anybody want to share out even just a word or just one example of maybe something or a thought?
For me, inquiry-based is basically open-ended prompts where I gave an example the other day. We were working on concentration. I said, did you guys hear about the lead concentration in the soil? Let's all look for that information and make sense of it.
Yeah.
And then just run.
Yeah, very good. Yeah, that's not only real world, that's like
Right
in their
their
world.
neighborhood. And
yeah.
that's what, they were more engaged because it's in their neighborhood.
Yeah, definitely. Yeah, good.
So they were supposed to find what the federal standing levels are.
Oh, okay.
And then compared to the results that were reported, and see how, what kind of effects that has.
Okay, very good. I know, see, it's like, I wish we had a list of everything that was going on around here, so that we'd be like, oh, that works for me.
Yeah. But that was, I got lucky,
Yeah.
because that was, real.
I mean, the fires around here really have kind of
Mhm.
done a lot of
Yeah.
that for science at least.
I put, excuse me, it's a learning material through hands-on activities that require students to solve problems or tasks. So like yesterday, I had my students out on the field, not on the dirt, but on the grass. And we were going, I had them on a big long PVC pipe, and we were going around in circles, and they discovered on their own that the people on the outside go faster. Rather than me telling them that,
Yeah.
they already discovered it. And today I'm going over and I'm actually giving them some background notes today to shore it up. And they're like, oh yeah, the guy on the outside went faster. So they lived it.
Yeah, they
Korea is
saw that
basically- it's
happen.
living it.
Ice skating and roller skating aren't common childhood activities around here anymore.
Yeah,
Right.
yeah.
Crack the whip.
All right, excellent, very good. So that's already some great ideas that are inquiry-based. But this can also kind of help teachers as well. So when inquiry-based strategies are implemented correctly, that puts more of the students in charge and makes the whole classroom more of a student-centered environment. It encourages them to question. And again, like I brought up the critical thinking, so many of them, I even see this with my AP students, have such a hard time thinking outside of the notes that they're given. And it's like, you don't have to write every single thing in the notes. Think about just an environment, an environmental change. And a lot of them are like, well, you didn't tell us one. Well, you see them all the time, so just getting them to feel confident in their own questioning and exploring and not knowing everything, which is obviously okay, which then leads to a deeper understanding through investigation. So these are the four main types of inquiry-based learning. Guided inquiry approach, we kind of already do that. We give them questions and kind of help them along the way. So like I said, in science, that one's kind of a given, along with the standard inquiry approach, which is common in science classes with lab protocols. So again, we kind of do that already. We give them the protocols, and it's kind of a structured procedure for them to follow. What we want to kind of work towards is more open-ended inquiry-based and problem-solving inquiry-based. So a perfect example that Vasquez said, coming up with a problem, a real-world problem, especially one that they can relate to, and bringing that into the classroom. Like I said, it's not always that easy, but when it is, use those opportunities to bring those into the classroom. And then open-ended inquiry is just giving them the opportunity. Here's what you need to figure out. How are you going to do it? I was thinking about doing that as I was doing this presentation, like with photosynthesis. I give all of my students spinach leaves, and we test oxygen and carbon dioxide levels. Well, I should bring like a variety of leaves, or tell them, bring in any leaves that you want, and then we can compare different types of, kind of leave it more open-ended. So working more towards open-ended and problem-solving would help to expand their critical thinking and problem-solving skills. So I've embedded a video here. I'm not going to play it, but if this were like a full PD session, we'd watch a video that demonstrates it's a Harry Potter analogy with inquiry-based learning. This is also in the resource slide that I provided at the end. So you can still see it. I'm going to send this to you all because the exit survey is at the end.
Okay.
So here's the activity that we're going to work on. These are 2 lesson excerpts. They're both from science classes. And your job is to read through these and analyze them using the inquiry-based checklist, which is provided here on the back. I also have a copy of these for you to take to your classrooms. I'm starting to do this with my lessons. You just kind of check off, does your lesson have this or not? And if they don't have something, even if you just try to start adding one thing to each lesson, you know, you could slowly integrate inquiry-based strategies.
Yeah.
So here are the two excerpts.
They're different?
Yes, so one of these is inquiry-based and one is not. So you might be able to tell just by looking at them. But some things that you want to kind of keep in mind, which is on your paper, what shifts do you see in the excerpt? So between 1 and 2, and how do students interact with the content in each excerpt? So those are kind of questions that you want to keep in mind. So again, if you were doing this on your own, I have them embedded into the PowerPoint along with the checklist. But since we're in person, you can kind of work on that on your own. Okay, I know that was not nearly enough time, but I'm gonna speed us along because of our time restraint. So just any quick observation, which one do you think is inquiry-based? Excerpt 1 or 2?
2.
Okay, 2. Okay, so what are some things that you notice about what the teachers and students are doing in 1 and versus in 2?
1 focuses on problems as opposed to questions.
Okay, so 1 is problem-focused, 2 is question-focused. Good. Brogan, what were you going to say?
Oh, I was gonna say that in 1, the students are just listening to the explanation, whereas in 2, they're answering questions and doing investigations to find the answers.
Yes, yeah, very good. So excerpt 1 is very kind of teacher-centered, and
Yeah.
the teacher's doing everything, whereas excerpt 2 is a lot more student-centered, where they're in charge of their learning and kind of where their questions are going to take them. So at this time, what we would do is break into groups and kind of make over your own lab or lesson. So everyone would pick a lab or a lesson and use this checklist to integrate some inquiry-based strategies. Like I said, not every lesson needs to include every one of those strategies, but if you could just include one even into something, that would make it more inquiry-based. That would lead to more problem-solving and critical thinking as students are learning the content. So, again, after you did this, we would then share these at our next department meeting, breaking into bio, chem, and physics. And then last thing here would be to create an action plan. So is there something in the next week from looking at that checklist, is there something that you could do, even if it's just starting the week off with a question and encouraging students to find that answer throughout the week? Any supports that you might need, this is all on that paper also. Just kind of think of instructional coach support, is there technology support, department support, and how will you know if your inquiry-based learning is working? How should assessments, obviously this is a huge process to alter assessments, but inquiry-based learning a lot of times has assessments built in. Because if students are answering these critical thinking questions, we can very quickly tell what they're understanding. Just as Traeger said, you knew that all the students understood that the ones on the outside went, so that question was very quickly answered, and as far as an assessment, that's a good quick assessment that you could take. So here are some provided resources. So again, the couple videos, some examples. I always really like having examples. I think examples really help to then, you could just kind of use the exact same structure, just cater it to your content. And questions, thank you guys so much for doing this. I very much appreciate it. I will need you to take this satisfaction survey within the next week. So I'm gonna send everyone out this PowerPoint, and just whenever you can, I would greatly appreciate it. I'm gonna have to
Okay, so we
do
don't
my
have
analysis
to
now.
copy that link down, you'll send us the.
I'm gonna send it to you and just, click on that. It's a, same thing, it's a Google form. I think it's
And so we're
8 to 10
supposed to bring our
questions.
lesson on Monday?